Chances are you've reviewed a restaurant today, or at least picked a customer satisfaction level on a survey. When we fill out those forms, we tend to treat our responses like exact rigid math. We assume a 4-star rating is exactly twice as good as a 2-star rating. But consider a survey where one person checks satisfied and another checks neutral. If you try to average those together, you can't legitimately say the result is a 2.5. The reason that math falls apart comes down to the underlying framework governing these surveys, Ordinal Data. To see why calculating an average rating is statistically flawed, we have to look at what this specific type of data is actually measuring, and more importantly, the crucial information it completely erases. The secret to Ordinal Data is right there in the name. It's rooted in the word order. It's a way of categorizing information where the groups have a natural, meaningful sequence. Think about a track race. When the event ends, the officials record a strict hierarchy of first, second, and third place. We have total certainty about the sequence. We know exactly who crossed the finish line ahead of whom. But this list of race results hides a massive unknown variable. The 1, 2, 3 ranking tells us James beat Marcus and Marcus beat Ryan. It doesn't tell us if James won by a single second or by 5 full minutes. That same dynamic applies directly to the tools businesses use every day, like the Likert scale found on customer feedback surveys. A very satisfied response is clearly higher in the sequence than a satisfied response. But the emotional distance between those two feelings isn't a fixed, uniform measurement we can precisely pinpoint. That is the defining dual nature of ordinal data. It perfectly guarantees the sequence of the items, while permanently obscuring the true distance between them. You see this dynamic in major societal hierarchies, too. A PhD is a step above a bachelor's degree, just as a general outranks a sergeant. But the amount of authority, effort, or time required to move from one step to the next is entirely unequal across the ranks. That unmeasurable gap is what causes the mathematical breakdown we looked at earlier. These examples of star ratings and satisfaction surveys highlight an absolute rule in statistics. Because the gaps are unequal and the values aren't true numbers, you cannot perform basic addition or subtraction across ordinal categories. If you attempt to calculate a true average, or mean, from a warped scale where the distance between 1 and 2 isn't the same as 4 and 5, you produce a completely artificial number. This means the average rating we rely on to pick a restaurant or buy a product is statistically invalid. It takes messy, wildly unequal human experiences and pretends they are uniform, rigid numbers. So if calculating an average is broken, statisticians use a different set of tools entirely to analyze ordinal surveys. Instead of a mean, they rely on the mode, identifying the most frequently occurring response, and the median, which finds the exact middle value in a ranked list. To see why those specific tools are necessary, it helps to place ordinal measurement within the broader spectrum of data types. This comparison table shows how ordinal data acts as a middle ground. It has more structure than basic nominal data because it follows a logical order. But compared to precise interval or ratio data, it falls short, entirely because it lacks equal known gaps. The rule to carry forward is simple. Ordinal data gives you the sequence, but it hides the gap. The next time you see a 4.2-star review, you'll know exactly what's going on behind the scenes. You're looking at a statistical illusion, trying to map precise math onto an immeasurable gap.